Thanks for coming back to the channel for a special feature. I've got a copy of the first and maybe only episode of Whitney's live sound workshop from 1994 called 60 Minutes to Sound Confidence. I was given this tape a good while ago and I digitized it a few years ago now. And I've tried to reach out to the folks involved in making it since then, but haven't had any luck. So at this point, I figured I'd share it here and see if anyone who watches this channel regularly remembers these videos, or if there were any more of them, or if you know any of the folks involved. We've seen a lot of the gear in this video in listings on recent episodes of Pro Audio Dealer Disaster here on the channel, so leave a comment if you have any memories of the classic 90s gear they are using here. You're going to want to grab a coffee and maybe something to take notes with, because this is a long one. Here's 60 Minutes to Sound Confidence.
Welcome to Whitney's Live Sound Workshop. In this tape, 60 Minutes to Sound Confidence, our purpose is to provide you with usable, hands-on information about sound engineering that we've picked up in our 30-plus years of combined engineering and stage experience.
I just want to say there's no magic running a sound system, but like anything else, if you want to be good, you've got to practice. Now, you'll make mistakes along the way, but that's how you'll learn. In 60 Minutes to Sound Confidence, we'll teach you the basics. General information that can be used on any sound system.
Like constructing a home, you start with the foundation on which the rest of the house is built. 60 Minutes to Sound Confidence is the foundation. Future videos in this series will build on this foundation. Through the confidence gained from a basic understanding, you'll be prepared to build your expertise in additional areas such as stage and miking techniques, power amps and speaker systems, house and monitor mix engineering, and even incorporating innovative new products into your current sound system.
Now that's in the future, but for the basics, here's what we'll cover. First, we'll explain what sound is. Then we'll examine each part of a typical sound system, from microphone to mixer to speaker. Next, we'll describe all the connections throughout the system. We'll pass on some helpful care and maintenance tips we've learned to help your system operate at its best. And finally, we'll walk you step by step through our simple sound check techniques.
Through Whitney's Live Sound Workshop series, you'll gain the knowledge and confidence to quickly set up your sound system and to produce a clear and dynamic mix like never before.
So sit back and enjoy building your expertise as a live sound engineer as we teach you the basics in 60 Minutes to Sound Confidence.
When an object vibrates or moves back and forth faster than 40 times a second, an audible sound is produced. Air molecules bump into each other, sending sound waves through the air, similar to ripples on the surface of the water when a pebble's thrown into it. These waves of air allow us to hear someone talking, music being played, or anything that produces sound. These waves push and pull on our eardrums, or a microphone's eardrum called a diaphragm. The number of times the vibrations move back and forth per second is called frequency, or hertz, abbreviated Hz. You'll see Hz on tone controls and other pieces of equipment associated with frequency. Our job as sound engineers is to capture sound on the stage or speaker's platform and to amplify it to the proper level or volume for the specific size audience in the room. This allows the performer to play, sing, or talk at a comfortable level on stage and be heard by a large number of people. Our primary purpose is to reproduce the natural sound of the performance with an increased loudness level. So let's follow sound as it travels through the typical sound system. Sound from any sound source, a singer's vocal cords or a guitar, for example, travels through the air in vibrating waves to the microphone. The microphone changes these vibrations into electrical pulses. The electrical pulses mirror the mechanical vibrations produced at the sound source. Then, the electrical pulses travel through the microphone cord to the mixing board and are made slightly stronger by preamping. This means they're amplified from mic level at the input of the mixer to line level at the output of the mixer. Next, the electrical pulses travel to the power amp, and the pulses are amplified to speaker level. At speaker level, the pulses of electricity are strong enough to energize the speaker. Here, these electrical pulses cause the speaker to vibrate back and forth just like the original sound, Only now, more air molecules are being moved, making the sound much louder or stronger. Are you beginning to visualize how a sound system works? The microphone's connected to the mixing board's connected to the, well, maybe it's not that simple, but you get the idea. The microphone converts sound to electrical pulses at mic level, the mixing board adjusts volume and tone at line level, and the power amp boosts line level pulses to speaker level pulses. Finally, the speaker converts the pulses back to mechanical vibrations that mirror the original sound, only louder. Now that you have a sound understanding of sound basics, let's investigate each component of the sound system. The very first component is the microphone. And this section will cover different microphones and their uses and the directional pickup of microphones. We'll also demonstrate phasing and give you some tips on microphone care. Although there are many types of microphones available today, there are two basic designs most commonly used in live sound reproduction: the condenser mic and the dynamic microphone. The condenser microphone is the most sensitive of the two, meaning it can pick up very weak sounds or sounds from a greater distance than a dynamic mic can. It's also excellent for capturing high-pitched sounds. This makes it an excellent podium mic or a choir mic where the person or persons may not be holding the microphone close to their mouths. The condenser mic is an excellent choice for capturing the sound of acoustic instruments such as the piano, flute, cymbals, acoustic guitar, or other stringed instruments. Treat the condenser mic like a baby. Rough handling will hurt it, and it's easily damaged if dropped. Inside the condenser mic is a very thin diaphragm that acts as an eardrum. The diaphragm is electrically charged. Behind it is a stationary metal plate with an opposite charge. As the diaphragm vibrates, it moves closer to and farther from the stationary charge. This creates small pulses of electricity. These pulses are boosted in strength by an internal amplifier called a preamp and made strong enough to travel through the mic cord to the mixer. Since this mic requires a preamp, it's necessary to power it with an internal battery or by use of external power called phantom power. Most mixers on the market have phantom power built in. If you're not sure whether your mixer has phantom power, check the owner's manual. If yours doesn't have one, you can purchase an external phantom power supply. The dynamic mic also has a very thin diaphragm inside, but with a coil of wire glued to the back. The coil is inserted into a circular groove that's been cut into a magnet. As the sound waves vibrate the diaphragm, the coil of wire moves back and forth in the magnetic field. This causes pulses of electricity to flow in the coil. These pulses are strong enough, so there's no need for a preamp, and no battery or phantom power is required. Since the coil is attached to the diaphragm, it weighs it down slightly, making it less sensitive than the condenser diaphragm. The dynamic mic is better suited for the road because it can survive rough handling. The dynamic mic works best when placed close to the sound source. It's ideal for handheld use and for loud sounds such as drums and instrument amplifiers. Both condenser and dynamic mics come in a wide variety of types and sizes for many different applications. Here's some of those mics and their uses. This condenser mic is about the size of a lipstick tube and can be suspended from above to pick up choirs or stage plays. When suspended by a thin cable, it's almost invisible to the audience. Smaller condenser mics, called lavaliers, can be attached to a performer's or speaker's clothing and remain inconspicuous. When needing a sensitive vocal mic, this same type of mic can be found in a standard handheld size. It can be used for a single person at a podium or used to pick up multiple singers. It's excellent for miking dramas or other stage presentations where performers such as children who have weaker voices can be difficult to capture. Another kind of condenser mic is a PZM, or pressure zone microphone. It can be placed flat on the floor to pick up sound on stage. It also works great for pianos, acoustic instruments, and even bass drums, where there's a closed space and all sound within that space needs to be picked up. When recording a large sound source, such as audience applause, it can be mounted on a wall and will effectively capture sound reflected from the surface of the wall itself. Dynamic mics are the workhorses that give live sound technicians the most reliability and flexibility. This is a standard vocal mic and probably the most common microphone found in live sound reproduction. This is a dynamic mic with a large diaphragm that makes it an ideal choice for bass drums and other bass instruments. It's also popular with radio announcers, since it can reproduce more quality in the bass or bottom end of their voices. This is just a small sampling of mics available on the market today. A future tape in Whitney's Live Sound Workshop series will further describe many other types of microphones and their specific uses, as well as how to place them for the best sound reproduction. With the various microphone types and their uses in mind, let's take a look at some interesting and important topics that may guide you in the proper use of microphones. The directional characteristic is an important aspect of both dynamic and condenser mics. Microphones are classified as either unidirectional or omnidirectional, according to the direction or directions that they have pickup sensitivity. Unidirectional microphones are used for a single source. This means they pick up sound best in one direction. Unidirectional mics should be pointed directly at the sound source, like shining a flashlight, and will pick up only the sound from that selected source. On the other hand, omnidirectional microphones pick up sounds from all directions. This type of microphone is used mainly in recording studios, where captured sound isn't projected into the same room as the microphone. Since these mics pick up sound from all directions, they can cause problems with feedback in a live stage sound system. Feedback occurs when projected sound from the system gets back into the mic, causing that familiar and unwanted high-pitched squeal. It's important to know how and why unidirectional mics cancel sounds from unwanted directions, so you can use them more effectively. Sounds that come from the rear of the unidirectional mic, say from monitor speakers, travel along the barrel of the mic. The mic has sound ports or holes on the side. Most designs have these ports close to the front of the mic, at the rear of the screen that protects the diaphragm. Some sound waves enter the ports and travel to an area behind the diaphragm, and some sound waves travel along to the front of the mic. The sound channels connected to the ports are designed to shift the sound just enough so it reaches the back of the diaphragm at the same time as the sound reaches the front of the diaphragm. Since the diaphragm is then pushed from the back and the front equally, it does not move. So any sound coming from the back of the mic is canceled. Sound coming from the front of the mic hits and moves the diaphragm, while sound entering through the ports hits too late to stop the diaphragm from moving. This allows the mic to pick up sound only from the direction in which it is pointed. Keep in mind that both condenser and dynamic mics can be either unidirectional or omnidirectional. The only difference between omni and uni mics is that the unidirectional mics have ports to cancel unwanted sound. Also, it's important to hold the microphone properly. If the mic is held too close to the diaphragm, the ports may be covered. When this happens on a unidirectional mic, it becomes an omnidirectional mic and can create feedback. Microphones are manufactured worldwide, which presents a problem when mixing the American standard and the European standard on the same stage. The American and European standard microphones are opposite in polarity. If they're used on the same stage, they receive the same sound wave, but one mic produces a positive voltage and the other produces a negative voltage. This causes an undesirable effect called phase cancellation. Phase cancellation causes a drop in volume and unwanted tonal changes. The best solution is to purchase microphones manufactured under the same standard. Here's a simple technique for determining if your microphones are in phase and compatible for use on the same stage.
Ed's going to explain the setup on a simple test you can use to check the polarity of your microphones and microphone cords. Ed?
Okay, basically you take the two microphones that you want to test and you plug them into two channels on your mixer. You'll want to make sure that the two channels on your mixer are set for equal volume and equal tone. The signal then comes out of the mixer, goes to the power amplifier, and then to a single speaker. We use a single speaker because it's easier to hear phase cancellation. Now with that in mind, let's try the test. This is the American standard, and this is the European standard, and this is a combination of the two. Checking 1, 2, 3, this is the American standard. I'm bringing the European standard to it. This is the two of them together. Now I'm taking away the American standard, and now I'm bringing it back up to it, 1, 2, 3, and there should be a difference when they're together. It should drop in volume.
As you can hear, phase cancellation can cause an unwanted drop in volume and distortion in your microphones. So Ed, what's the best solution to this problem?
Well, probably the best solution is to just purchase all the same type of microphones.
And if I don't have the money to replace my microphones?
Well, you can buy a unit like this. It's called a phase inverter. It turns around pins 2 and 3 inside of it. If you don't have one of those, you can solve the problem by taking the end off of one of your mic cords and turning around pins 2 and 3 on it.
And then that dedicates that microphone cord to that particular microphone.
That's right. So you want to mark this cord for this particular mic.
Always purchase low impedance microphones and balanced microphone cables. High impedance microphones are becoming a thing of the past and should not be used in a professional sound system. Low impedance mics are much less susceptible to noise and hum, and they'll match the voltage and current in your mixer's input. One last topic on microphones is care and maintenance, which is often overlooked. Cleaning and maintaining your mics can be quick and easy. Proper care will improve the sound, appearance, and life of the mic. Dirt in the microphone screen can block the passage of sound to the diaphragm and begin to degrade the quality of sound produced. Did you know that you can help keep your microphone screen clean right along with your dirty socks? Just remove the steel windscreen from the body of the microphone and put it in an old sock. Tie a knot in the sock to keep the windscreen from coming out. After completing that step on all your microphones, put the socks in a pillowcase and put it in your washing machine with some towels and other clothes. Using cold water and a small amount of detergent, set the machine on the gentle cycle for about 10 minutes. Afterwards, rinse the screen under cold water and make sure it's dry before reassembling the microphone. Frequently clean the body of your microphones with a clean, damp cloth only. With just a little attention, your microphones will last for years and sound their best. The next link in the sound chain is the microphone cord. A balanced system is essential to minimize noise or hum that can be picked up from external sources. Unwanted interference, noise, can come from power cables, house lights, dimmers, fan motors, even refrigerators, and other stage equipment too. Here's what a balanced system does to remedy this noise interference. Most mixing boards use low impedance balanced XLR inputs for microphones. Balanced cables utilize 3 wires. On the pin face of the XLR connector are the numbers 1, 2, and 3 next to the pins. Using the American standard, the shield, which surrounds both the hot and neutral wires, is connected to pin number 1. The shield helps block out signals traveling through the air, like hum from lights and radio signals. The hot lead is connected to pin number 2, and the neutral wire is connected to pin number 3. A tiny transformer inside the microphone connects the mic components to the output pins where the cord is plugged in. There's also a transformer in the mixer at the channel input. These are the devices that cancel out noise picked up by the mic cord on the way to the mixer. As the interfering signal meets both conductors, it causes equal voltage on both lines in the same direction. These voltages arrive at the transformer at the same time and are canceled. Signals generated by the microphone cause pulses of opposite polarity to flow in the center conductors. This signal won't be canceled by the transformer and causes a current on the amplifier or mixer side of the transformer. Mixers and amplifiers that use transformers to balance their inputs are the most effective in eliminating interfering signals from lighting and high RF sources, such as radio broadcasts. If you use a large number of mic cables in temporary situations, it's best to safely store them on a cable reel. Here's a useful tip for storage of mic cables.
Okay, Ed, I've just disconnected all the microphones from all the mic cables, and I've also disconnected the mic cables from all the amplifiers. We should be ready to pack them up.
Okay, great. We've come up with a real simple method for storing mic cables. This is just a typical hose reel, and you wind the cables on. You want to make sure that you leave the female end of the cable out so that the male end, which is the typical end that you plug into your snake box, is ready to plug on. We just simply wind the cord on, and this makes it really quick and easy for cleaning up your stage. Okay, just hand me the last cord. We'll plug it on here and wind it on. Boy, that was quick and easy.
Yeah, in just a few minutes, we've picked up all of our mic cords, wound them on here, got a nice, neat, clean, and compact package ready for the next show.
Balanced connectors are important and useful, but unbalanced cables are still in use in almost all sound systems today. An unbalanced system uses only 2 conductors. A guitar cord is a good example of an unbalanced cord. It's normally a 1/4-inch phone plug with only 2 wires or conductors inside. The center conductor carries the positive voltage, and the shield, or ground, carries the negative voltage. If a strong radio signal is present or hum is being given off by lighting, this unbalanced system will not reject it. The unwanted sound will be carried through the sound system and amplified. So if you're trying to find the source of AC hum, check the unbalanced sources first. Once you pinpoint the offending instrument or amplifier, plug it into another outlet. Or check for a ground lift switch on the amplifier. You can also try a higher quality instrument cord. And if you're using a direct box, place the direct box on the floor away from any noise-inducing amplifier or power supply. Sometimes, no matter what is tried, a noise on a particular instrument will persist. You can adjust it low in the mix, bringing it up only on solos. In some cases, you can get higher quality sound by connecting the sound source to a direct box and then connecting the direct box into the sound system. Several types of direct boxes are available for use as an alternative to using a microphone. Earlier, we discussed 3 different power levels of signal in a sound system: mic level, line level, and speaker level. Here are Ed and Jeff to offer some advantages of using a direct box and how to capture the signal from a sound source at all 3 signal levels.
One of the advantages of using a direct box is it allows you to pick up just the sound that you want to hear. A live microphone, for instance, may pick up an instrument that's right next to it that you really don't want to hear in that particular channel. Another advantage is the signal coming out of a guitar amp, for instance, is an unbalanced signal. The direct box balances it, sends it down a longer length of cable without picking up any kind of electrical noise.
The direct box will also isolate unbalanced equipment from your phantom power supply. If you're using condenser microphones on your stage, you'll be using phantom power. Another feature you might find is a ground lift. This can be used to control electrical hum through your system. Ed, should we hook a few instruments up?
Yeah, let's do it. We've drafted Alex to help demonstrate how to hook up an acoustic guitar to a direct box. Basically, what I have here is just a regular guitar cord, which is an unbalanced shielded cord. We hook it into his guitar, and then we hook it into the front or the input of the direct box. Then we take a short patch cord, patch it on the output of the direct box down to his amplifier. Now what that allows Alex to do is be able to control his sound up on the stage via his amplifier here. And on the back of the direct box, there's a microphone input that allows us then to take a balanced signal out of the direct box, send it down our mic snake, and control the amount of guitar that we want him in the system out front.
This instrument is a line level instrument. It's got a built-in preamplifier powering the line level output. One option to connect the keyboard to your PA system is to use a direct box similar to what you just saw. There's a simpler option available as well. This is an inline transformer which you can use through your line level output, and just a simple connection with the microphone cord connects that signal right into the PA, and it's just that easy. We've got a direct input. Lead guitar players often prefer to have the sound of their speaker brought out to the PA versus having a direct box run from your amplifier output. Ed's got this lead guitar plugged into his amplifier and a standard input, so he'll use the amplifier on stage as his stage monitor. What we want to do is capture the sound of his speaker and send that to the PA system out front. We'll use an electronic direct interface or an EDI box to capture that signal. I'm using a standard unshielded speaker wire here. On this amplifier, we've got an external speaker out, so we'll take this signal from that external speaker out and plug it right into the input of our EDI box. Using the EDI box, just like the earlier direct box, we'll take a microphone cord into the balanced output, and that'll run the signal to the snake and out to our mixer out front. Now we've captured this at a speaker level and sent it right to the mixer out front so we can control the volume of sound out front exactly from his speaker without affecting the sound of Ed's guitar at all.
To engineer the sound mix from the audience area, which is the best place to do so, you'll need a microphone snake. The snake is a single bundle of all the mic cables in your system. Snakes can be bought in the length that you need and with the number of mic cords you need. The snake inputs are usually balanced XLR connections and will have jacks for all of your source channels, along with several extra channels called returns. It's best to have XLR-type returns to balance your system, even though some snakes use quarter-inch connectors on the returns. At the other end of the snake, the individual cables are unsheathed, creating a fan of cables that plug into the mixer. This is called the snake fan. The channel and return connectors are numbered or labeled to make hookup easy. Proper care and maintenance of the snake can be cumbersome and is often overlooked. Here are some tips that will help keep your snake in top shape. Periodically, you should clean the snake with a damp cloth and mild soap solution. Also, be sure to tear away any tape that might remain from previous remote setups. The contact points of the snake box and fan connectors should be cleaned with carbon tetrachloride or a standard contact cleaner found at most electronics stores. Simply spray the fluid into each connector, wait a few seconds, then insert each into an opposite connector. The best way to keep your snake pliable, straight, and free of damaging tangles is to keep it on a wind-up reel. This is also convenient for storage and transportation. Storage reels like this come in various sizes to accommodate cables of any size and length. A low-cost snake reel can be built using a wooden spool commonly used for industrial wire storage. Attach the spool to a spindle, mount the snake input box to the top of the spool, and wind up the cable for storage. During setup, the fan can be pulled back to the mixer position while the extra cable and spool remain on stage. Next stop on our trip through the sound system is the mixing board. The mixer is probably the most complex and least understood component in the common sound system today. Here we'll discuss placement, mixing techniques, the signal path through the mixer, and some maintenance tips. The position of the mixer in relation to the stage and main speakers affects both your judgment in mixing, tone, and levels, as well as your visual contact with the performance. The sound engineer must hear exactly what the audience is hearing in order to make the proper adjustments to volume and tone. Whether you're planning a permanent installation or laying out a temporary stage setup, it's crucial that you plan ahead to place the mixing board as near the listening audience as possible. The ideal mixer position is about 2/3 of the way between the stage and back wall, and just slightly off-center. This allows you to hear what the audience is hearing and make good judgments on volume and tone. If you're using 2 speakers, one on each side of the stage, there's another rule of thumb for positioning the mixer. Measure the distance between the speakers and make an equilateral triangle between the 2 speakers and the mixer. Again, stay a little off dead center to help eliminate phasing problems that cause unwanted coloring of the amplified sound. This is also the point at which stereo imaging is most pronounced, if you happen to be using a stereo system. Even after investing in an expensive sound system, many people have gone to elaborate means to place the mixing board behind glass in another room. This is effective for recording. However, nothing could be worse for mixing live sound. You've got to hear what the audience is hearing. Every sound engineer has their own style, and this adds variety to the sound we hear. There are some basic rules, however, that all good sound people follow. Picture the sound mix as a pyramid. Vocals are always on top. They should be the loudest and most dominant. They must be clear and easily understood. It can be quite frustrating to listen to a music group and be unable to hear or understand the words because the vocals are mixed too low. The next level down on the pyramid is the bass guitar, or whatever bass instrument is used. If drums are part of the group, the snare drum and bass or kick drum should also be on this level, and all 3 at about the same volume. These instruments give power and punch to your mix. If you mix sound in a place where people want to dance, and the bass and drums are not in the right place in the mix, the people aren't as inclined to dance. Put the bass and drums in the right place, and people will flock to the dance floor. Club owners want people to dance and have fun, so they'll return. The band's job security is dependent upon you getting the right mix. Under the bass and drums is where the rest of the instruments fall: guitars, keyboards, piano, and rhythm instruments. These instruments are in the same frequency band as vocals, so they have to be mixed low enough so they don't cover the vocals. When a solo is encountered, these instruments should be brought up to match the vocal level, but only if the vocals are not present, and only if the stage volume of the instrument does not compensate from the stage. When the solo is complete, the volume should be returned to the original level. Remember, always listen carefully to the vocals and make sure you can easily understand what's being sung. We'll get back to more mixing techniques later during the sound check. So far, the sound has traveled through the air to the mic, been converted to electrical impulses, traveled down the mic cord, and is now ready to enter the mixer. The sound mixer is often referred to as the soundboard, mixer, or console. Mixers come in a variety of sizes and configurations. We'll refer to a simple mixer so we can easily follow the sound flow. The controls in our mixer are common to most, though they may not be in exactly the same place on your particular mixer. A mixer can be divided into individual sections: input channel, dynamic section, master section, patch bay, and output section. The incoming mic cable is connected to the channel input on the mixer. The signal travels to the input attenuator, which is usually the knob labeled gain or trim. There may also be a switch located nearby which lowers the signal strength in larger increments. This assures that the signals which are too strong for the electronic components in the channel are reduced to the right strength, so it doesn't overload the channel. Similar to a water valve that restricts flow and allows the right amount of water to run through a pipe. Overloading the channel causes a raspy sound, referred to as distortion. Most mixers today have a small light on each channel that lights up, indicating that the input is too strong. After leaving the gain control, the signal branches in two directions. Equal signals go to the monitor send and to the tone or EQ circuit. Because the signal branches to the monitor control before going to the tone circuit, the monitor signal is called pre-EQ send. This means the signal is captured prior to entering the tone and volume circuits. The advantage to you as a sound person is that the monitor mix is not changed when tone or volume adjustments are made for the audience. Some mixers label these monitor or auxiliary sends aux1, aux2, etc. Read the manual for your mixer and be sure to pick the auxiliaries that are pre-EQ for your monitor sends. The monitor mix is what the musicians and performers hear from the monitor speakers on the stage. The monitor signal can be adjusted for volume on each channel using the monitor or aux controls. This creates the mix that joins at the master monitor control in the master section of the mixer, usually on the right side of the board. This master control adjusts the volume of the entire monitor mix. Now let's return to where the signal branched after the gain control. An equal portion of the signal went to the tone or EQ section of the channel. This is where you become creative and add or subtract treble and bass to the sound to improve it or EQ it. Most mixers have at least a high, treble, and low bass control. Many mixers have a mid-range control, a sweepable mid-range control, or even multiple controls to enhance the middle tones. Next stop for the signal is the volume control or fader. Most mixers use a fader that slides in a slot rather than a knob. This makes it easier to make smooth adjustments and tells which volumes are up at a glance. This is the control that adjusts audience listening volume. Now the signal is going to branch equally again in two directions. One to the effects send, sometimes called post-fade aux send, and the other to the pan control, which sends the signal either to the left or right side of the mixer's main master section. We'll follow the pan path first, then come back to the effects path. The signal that comes to the pan has been adjusted for volume and tone and is now being routed to the master section of the mixer. If your mixer is not stereo, you won't have a pan control and the signal goes straight to the master volume. If you do have a stereo mixer, the pan is a handy tool when submixing while running the system in mono. Mono means that both speakers have the same sound coming from them. All the vocal mics can be panned to the left submaster, and all the instruments panned to the right submaster. This makes it very easy to control the volume of the vocal group and the instrument group by the use of only two controls. If you choose to run your system in stereo, vocals and instruments can be moved in the stereo image by panning left or right. Panning a vocalist to the left, for instance, will make it sound as if he or she is standing beside the left speaker. Don't pan a voice or instrument too far to the left or right. People sitting on one side or the other may not be able to hear something panned completely to the other side. In live sound situations, it's better to just pan slightly or run the system in mono. Mono allows everyone to hear everything coming through the system equally. no matter where they're seated. After leaving the pan control, the signal is routed to the master section of the mixer. Some mixers only have a left and right master volume, like ours. Larger mixers can have numerous sub-faders, which help break down mixes that contain large numbers of instruments and vocals. These master subs control the volume of groups of channel faders that have been assigned to them. From the subs, there is often a master control called a sum or master. After internally combining the signals of the sub-faders, the sum controls the final volume of the entire mix that will go to the power amplifier through the sum or master output jack. Now let's go back to the channel fader and pick up the signal that branched to the effects send. This signal is also post-fader, which means it's controlled by the channel fader. The amount of signal sent to the effects master from each channel is controlled by the effects or post-aux control. The effects signal from each channel ends up at a volume control in the master section called effects master or aux master. The signal goes out to the effects unit from the effects master and is brought back into the mixer through the effects return or aux return. This control feeds the affected signal to the master volume so the sound it produced can be heard. On most mixers, you'll also find a pan control that accompanies the effects return. This control allows you to assign the affected signal return to the sub-fader you desire. If your mixer does not have a separate effects return, an open input channel can be used. Let's pause here and review the different mixes we can have. The monitor mix is what is heard on stage or on the speaker's platform. The main mix is what the audience hears. And the effects mix is adding reverb, delay, chorusing, and other effects to the main and monitor mixes. The monitor mix comes out of the mixer from the monitor out jack. These output jacks can be 1/4-inch female phone jacks or 3-pin XLR male jacks. Some mixers call this out aux1 or aux2, etc. This output is routed through your snake or a signal cord to your monitor system. The next mix is the main or house mix. The main signal is routed from the main output jacks to your audience amp and speaker system. The main output jacks are labeled as stereo left and right, main A and main B, or main 1 and 2. If you're running your system in mono, use the sum or master output jack. Bear in mind that not all mixers will be equipped with this feature. Finally, the effects mix will be connected to the effects unit via the effects or auxiliary outputs. The effects mix is the only one of the 3 mixes that is returned to the mixing console. It enters through the effects return or through an input channel. Effects allow you to manipulate an instrument or a voice to sound like anything from singing in the shower to yelling down a mine shaft. New effects devices come out every year to enhance and improve the sound of singers and instruments. The complexity of effects units is beyond the scope of this video, so we'll cover effects in much greater detail in an upcoming video. There are a few simple things you can do to extend the life of your mixer and assure that you get the best quality sound possible for many years. As with most electronics, cleanliness is important. An easy way to clean your board is with a damp cloth and a touch of Armor All. Armor All will remove dust and keep it from adhering to the surface, plus protect the control labeling from wear and scuffing. Another tip is to use a clean, unused paintbrush for frequent dusting between the knobs. Also, vacuum the mixer from time to time using a brush attachment. Periodic cleaning of the contact surfaces with a contact cleaner will help ensure good connections on the input and output jacks. Having completed an overview of the mixing board, now it's time to move on to the next link in the sound chain, which is actually a combination of the power amp and speaker system. They're usually 2 separate amplifier and speaker systems, which are the monitor system and the house or main system. For now, we'll move on to monitors, and we'll return to more details on the main system and its individual components. We'll do an overview of the monitor system, visit the EQ, and show you how to eliminate feedback. The monitor system, or stage monitor, is a critical part of most live performances. Monitors allow musicians and singers to hear their performance relative to the others on stage. In large productions, each performer may require an individual monitor mix. Under these circumstances, monitor systems can become quite complex and may even require an exclusive mixing system called a monitor mixer or stage mixer. These more complex systems will be covered in a future Whitney's Live Sound Workshop video. But for now, we'll cover the monitor system and techniques used for mixing monitors from the main board. The monitor output of your mixer is routed through a cable to the monitor system, which is comprised of an equalizer, power amp, and speaker system. The signal is routed first to the input of the equalizer. A common type of equalizer is the graphic equalizer, or EQ, seen here. This unit controls the volume of each frequency band, starting with low frequencies on the left, moving to high frequencies on the right. A graphic EQ is an invaluable tool for making adjustments for room acoustics and affecting the overall tone of the system. When air is placed in a box or in a room, it vibrates at certain frequencies better than others. These are called the dominant or resonant frequencies. In a larger room, the low frequencies vibrate easier. Smaller rooms accent high or mid-range frequencies. Soft surfaces absorb sound, which is most noticeable in the high frequency range, and hard surfaces reflect sound. The goal is to determine what the dominant frequencies are and reduce them to the same level as the rest of the frequencies in the audio spectrum. This makes our PA sound full and helps eliminate feedback. The dominant frequencies are the ones that will feed back first. This is especially important to eliminate these in the monitor speakers, because performers often want their monitors to be as loud as possible without feedback. The process of eliminating feedback is called ringing out the system. Here's how it works. First, you must find the dominant frequencies in the room and reduce them to normal levels by finding them on the equalizer. This process can be tricky and requires careful attention to avoid damage to your equipment or your hearing. Here's Ed and Jeff to show you how it's done.
One of the most important mixes in live sound production is the monitor mix. The monitor mix is a little more prone to feedback because of the close proximity of the speakers to the microphone. The sound of the speaker comes out and gets into the microphone and circulates through the system until we get that unwanted sound called feedback. The unit that we use to eliminate feedback is called the equalizer.
It's a good idea to clear the stage before ringing out the system to save your performer's ears. Ed, you want to hop down for just a minute?
Right, I don't want my ears to burn.
Also, the quieter that you can get the room, the less time it'll take.
Okay, we start the procedure by simply increasing the volume on the monitors on stage to the point of where they just begin to feed back. We're going to be looking for one frequency that's starting to ring. That's the frequency we want. Now, what frequency do you think that was, Jeff?
That was in the neighborhood of 800 hertz, Ed. I'll just pull it down a little bit.
We've been doing this for a while, so after a while you can kind of tell where they are. Now that was a middle sound. Now after we pull that out, another frequency the next dominant frequency should start to ring. What frequency do you think that is?
Ed, that'd be in the neighborhood of 5K, don't you think?
Okay.
5,000 hertz.
Somewhere up there.
And I'll bring out 5,000 and just a little bit on the faders just beside it as well.
That'll sort of round out the sound a little bit.
And now we're on the lower end of the spectrum. Ed, just how many different frequencies should we pull out?
Well, probably 3 or 4 would be the maximum. Otherwise, you'd continue to keep ringing it until all of a sudden you've got them all pulled down, and then that throws away all the volume that you would normally have on stage. Now let's see what kind of volume we can get without any feedback on the stage. Check, 1, 2, 3, check, check, check. That's plenty loud and no feedback. A handy tool for ringing out your system is called a spectrum analyzer. It takes the guesswork out of figuring out what frequencies are feeding back. Let's try it and see if we can get it to work. I'll turn it up a little. Okay, what frequency is that, Jeff?
That's 500 hertz, Ed.
500 hertz. So we would know to be able to just go over here to our equalizer, pull down 500 hertz. We'd go to the next frequency. We'd look on here and simply find out what frequency it is, pull it down, it makes it a snap.
Some portable sound systems have the power amplifier built into the mixing console. This type of mixer will have speaker-level outputs that can be connected directly to the speakers. On more versatile systems, the power amplifiers and console are separate units. All outputs on an unpowered mixer are line level when leaving the mixer. They're not strong enough to push speakers, so they must be made stronger or amplified. The power amp's job is to amplify the line level signal to speaker level. The amount of power the amp has is measured in watts. On the back of the power amp, there is a power output rating next to the speaker output. If it's not there, check the manual for the RMS wattage output. Always purchase the highest power rated amps you can afford. This will provide more headroom, which is power in reserve, and will assure the amps are not overworked. Also on the rear of your power amp or powered mixer is a rating for the minimum ohm load. It's important to match the power amp's ability to push or drive the speakers with the load or impedance the speakers place on the amplifiers. The rating on the amplifier must be lower than or equal to the load from all speakers connected to it. Here's a simple formula for determining the ohm load. 1 divided by 1 over R plus 1 over R for each speaker powered by that amp. The R in our formula represents the resistance stated in ohms, which is usually marked on the speaker enclosure near the input jack. Using two 8-ohm speakers, the formula would look like this. Another method to remember is that whenever you double the speaker load, the ohm rating of the speaker load is cut in half. This makes for quick figuring when you need to add additional speakers to an existing system. Here's another example. Let's say we have a power amp rated at 4 ohms connected to an 8-ohm speaker. This would represent an 8-ohm load currently on the power amp and wouldn't pose a problem. Using our formula, when you double the speaker load, you simply divide one speaker load in half, which gives you a 4-ohm total load. Since the power amp in our system is rated at 4 ohms, there's no problem using two 8-ohm speakers. But what if our stage setup required still more speakers? Since we're at the rated load of the amp, adding any additional speakers would create a load below the amplifier's capacity. Now here's where our simple formula can forewarn you of problems. If we again double the speaker load by adding 2 more 8-ohm speakers, we need to divide the total ohm load in half again, making it 2 ohms. This load of 2 ohms is below the rated capacity of the amplifier and will cause the amplifier to be overworked. As you can see, this formula is quick and simple and can be very helpful when working with an even number of speakers. If you need to find the load rating for an odd number of speakers, just remember that the formula is 1 over 1 over R. Whether you use a mixer with the power amp built in or if you use an external power amp, make sure it has good ventilation to avoid overheating. Always try to run your power amps on the same electrical circuit as your mixing board. The best way is to choose an electrical outlet near the stage to run the power amps, and from the same outlet, run a heavy gauge extension cord to the mixing console to power it. It's also important to avoid sharing the same electrical circuit with fans, lights, air conditioners, and other noise-producing electronic equipment. Powered mixers have a power amp built in and are simpler to hook up. The speaker lines hook directly in, so no additional wiring is needed between the mixing board and an outboard amp. Powered mixers should not be used for running sound from the audience, since long speaker lines would be required. Lengthy speaker wires have a tendency to dampen the more powerful sounds like bass drums and other low frequencies, causing them to sound mushy. If the sound is going to be mixed from the stage, powered mixers are very convenient. If the sound system will be run from the audience, an unpowered mixer is the right choice. Unpowered mixers send a line level signal to the power amps through low impedance cabling, which isn't affected by long distance runs. The power amp can be placed in close proximity to the speakers, thus eliminating the dampening effect associated with long speaker wires. And remember, use a balanced line to send your line level signal to the power amp. Now let's cover the next link in the sound chain, which carries the power from your amplifier to the speaker or speaker system. Speaker wires carry the highest current load of all cables in your system. So the heavier the gauge, the better. Just like larger pipes can carry larger amounts of water than smaller ones, heavier wires can carry more electrical power. Thicker cables carry more current to the speakers and waste less energy. The smaller the gauge number, the thicker the wire. For example, 10 gauge wire is thicker than 14 gauge. Don't use anything smaller than number 16 for short runs, and to run close to 50 feet should be at least 12 gauge. Never use shielded wire, such as guitar cords for speakers. The shield adds an electrical property called capacitance, which makes the amps run hot, wastes power, and even causes the amp to shut down. Speaker wires are the only audio wires in your system that should not be shielded. All other audio cables throughout your system should be shielded. After the signal has traveled through the speaker wire, we arrive at the last component of the sound system, the speaker. The speaker components resemble those found in a dynamic microphone. The coil of wire is attached to a diaphragm called the cone. The coil of wire is put into a groove cut into a magnet. As pulses of electricity from the power amp flow through the coil of wire, the coil acts like an electromagnet. It pushes and pulls against the magnet, pushing and pulling the cone. The cone mirrors the movement of the diaphragm in the microphone, only now pushing more air, making the original sound much louder in volume. There are many types of speaker systems in use today. Some are two-way, three-way, four-way, etc. A speaker system may have several individual cabinets, while some speaker enclosures may contain multiple drivers. A two-way system uses a bass speaker to reproduce low sounds, and usually a horn or tweeter for the high-pitched sounds. There's a device called a crossover that divides the audio signal into two parts, high frequencies and low frequencies. The high frequencies are sent to the horn, and the low frequencies are sent to the bass speaker or driver. If an active crossover is located before the power amplifiers, and one amp is powering the low frequencies, and the other powering the high frequencies, this would be called a bi-amped system. On the other hand, a single amplifier can be used to power a two-way cabinet with a passive crossover located in the cabinet. Speaker design has certainly come a long way since the days of the Victrola. Be sure to catch our upcoming segment that will explain in more detail speaker use, biamping and triamping systems, and new technologies in speaker design. Now that you have a basic understanding of the sound system and its components, the next step is to improve your skills in sound engineering with a little hands-on practice. To get a better grasp on how sound flows through the system, let's route a sound source to different sections of the system. First, plug a CD or tape player into your mixer input channels. To connect a tape or CD player, the best method is to bring the out from the deck to high Z in on two spare mic channels. This allows adjustment for tone, volume, and allows the playback to be sent to the monitors. Some mixers have a tape input, but for now, let's use a microphone input channel. It's usually necessary to use cords that have an RCA connector on one end and a 1/4-inch plug on the other. While playing a tape or CD, you should practice routing the signal to the 3 output jacks. Route it to the monitors, to the main speakers, and then to the effects send. A single amplifier and speaker system can be used to check your output by changing the output jack, which connects the mixer to the amp and speaker system. If your mixer is equipped with a headphone jack and a Q, solo, or pre-fade listen system, you can also use it to listen to your work. After mastering the use of different outputs on your mixer, some practice with a single microphone or instrument routed through your effects device can get you familiar with its functions. These special effects can add that professional touch to your performance and will set your mix apart from the norm. Take advantage of band, drama, or choir rehearsals because practice builds technical confidence. Then you can focus on getting the best sound mix instead of thinking about the mixer controls and their functions. Now let's put your sound confidence to work and run through a sound check. A sound check is important because it allows you to set the system to the performance at hand. Even if the same system is used in the same environment every time, things change. The mic may be changed and put in a different place. Someone may have adjusted a keyboard or amp differently. The room may have a different number of people in it. All these things require some listening on your part for changes in volume and tone for each mic or sound source in your system. Let's go over a generic sound check list. With everything arranged on the stage like it will be used during the performance, we'll start from scratch with mixer controls first. Our first step is to normalize the mixer for a safe setting prior to turning on the power amplifiers. Start with channel 1 and turn the gain or trim off. Repeat this on all input channels. The tone control should be set flat, that is, in the middle or straight up, so that they're not adding or subtracting tone. Repeat this on all input channels. Turn off the effects sends or auxiliary controls, and again, repeat this on each channel. The pan control should be set to assign each input for the submix desired. Now, assure that all channel faders and master volume controls are in the off position. At this point, we're prepared to safely turn on the power amplifiers for the house and monitor speaker systems. Also, turn on your effects units or any outboard gear you'll be using. Now, set the master controls for your house system at or near unity gain. For most mixers, the point of unity gain will be marked as 0 dB, or about halfway up. Repeat this step for the subgroup faders, the master monitor, and the master effects controls. Use a tape or CD player, connected as described earlier, to check the operation of your main and monitor speaker systems.
One easy way to check for the 3 mixes that you have in your sound system is to use a tape deck. We simply hook the tape deck into 2 channels and then play the tape and use the tape to send the signal to the inputs of these channels. In this case, we're going to adjust the gain controls on these channels for a green light. Now, your mixer may only have a red light, which is a peak light, and you can turn it up till you see that peak light start to come on and then back off a little bit. Then at least you know you have a signal going into that particular channel. The first mix we're going to check is the monitor mix, and Jeff will explain how we do that.
First of all, we're going to select monitor B system here to check if the monitors are working. First, we want to raise the monitor master, and then we want to go to that individual channel and bring up that monitor send on that channel. And as you can hear, we've got working monitor system. And now we'll go and to check the main system.
Okay, now to check the main system, all we do is we still know we have a signal coming in up here. So all we need to do is make sure that our master is up for the main output, which Jeff's going to bring up A.
We're panned to main A, and so we're going to bring up the master on main A.
And then we simply bring up the fader on that particular channel. Now you can see that the main speakers are working. The only other mix we need to check now is the effects send.
As we mentioned earlier, the effects sends are post-fader, which means if these faders are not up, we're not going to get a signal here regardless of the placement of the knobs. So first thing we need to do to check our effects mix is make sure that our faders are up on the individual channels. These faders are going to feed the master, and so we need to be sure that our effects master is at unity gain or at 0. At this point, we can grab the effects send on a channel and turn it up until we get a green light indicating that we do have a signal.
Then, it's time to set volume levels and tone on each channel. Have a helper, or preferably a performer, check the mic that is plugged into channel 1. Have them sing or talk with the same strength as their strongest volume used in the performance.
We're going to start with the vocal microphone. It's important to hear the vocals in the front system as well as in the monitor system. We start by setting our board to what we call unity gain. That is, we slide the slider up to the 0 position on the particular channel, and then we come over to the master section and we do the same thing there. Now it's time to set the input to the channel and adjust it for the right kind of input so that you don't overload the channel. Jeff, do you want to start?
Check 1, 2. Check. Checking 1, 2. Check 1, 2. Checking 1,
Watch for the channel overload light. If it is blinking, turn the gain down until it just barely blinks on peaks. Some mixers distort if the light blinks at all, so listen for distortion. With the gain adjusted, we can make any tone adjustments required. Listen to the voice. Does it sound natural? If you can't easily understand what's being said, add sibilance by turning the highest tone control to the plus side. By increasing the high frequencies, the consonant sounds like S's and T's are accented, making words more easily understood. If the voice sounds thin, try adding a little mid or low tone. Listen to what happens when you turn the tone control to the left, the minus side. Sometimes it's better to subtract lows if the person sounds muddy instead of adding high frequencies. Experiment. Don't over EQ, just make slight adjustments. Repeat the process of setting the volume and tone controls for each input channel you use in your mixer. When you're satisfied with the volume and tone of each channel's sound through the main speaker system, you're ready to attack the monitor system. Since we should have the monitor master control set to unity gain, we can quickly set the monitor volume on each channel by adjustment of the monitor send controls. Have your helper test each microphone for proper stage monitor level, then complete the monitor mix by adding any instruments that the performers require. With all levels set, you should ring out the monitor system using your equalizer as described earlier. Now let's set our effects, if you're going to use any. If the room is very live, lots of hard surfaces, you may want to keep reverb and delay to a minimum. The effects master should be at unity gain as described earlier. We need to select the effects return and set the input level at unity gain here also. Adjust the effects units controls for input and output to about halfway up. Then adjust the effects sends on each channel to your liking. Keep in mind that the effect will not be as dominant when the group is singing or when music fills the background. At this point, we're ready to check the mix of the performance. A short segment of the performance should be used to make final mix adjustments. Remember to picture the pyramid and carefully listen to the vocals. There you have it, 60 minutes to sound confidence, the basics. Take what you've learned here and apply it to your particular sound requirements. Go back and review parts of this video as needed, and keep it nearby for quick reference. And remember, this tape has provided you with the foundation. We hope that you find this information useful and that you'll use these techniques on your next performance. As you build your confidence as a live sound engineer, you'll find that we've only scratched the surface of the information we want to provide. We're always working to bring you the most accurate and useful information on live sound technologies. Please contact us for more information on future videos covering subjects on sound for worship, school drama and choir, and concert sound. Here are some future videos in Whitney's Live Sound Workshop: the stage, engineering the console, a close look at monitors, power amps and speaker systems, and staging and lighting. Thanks for joining us on this tour of the sound system. We trust that you found it enjoyable and informative. Now, all you have to do is put your sound confidence to work for you.